Hello, welcome to everyone in this today's video. So we are going to learn today itself about cell. Cell is what and where we are using this cell. So as we are known in our daily practice life that cell we are using in the torch, cell we are using in our wristwatches, that cell are used in combination in the that of inverters. Okay, so there we are having the different uses of the cell, but why we are using this cell? So therefore, because they are maintaining the potential difference. So what is this cell? So it is a device which maintains potential difference in the circuit. Potential difference. Okay, so as we are known, it's of about that even though there are the free charges in the conductor, but still they are not going to move by themselves because at room temperature they have their random motion, so they do not have any definite direction. So therefore, to provide them a definite direction, there should be potential difference, and for this potential difference, we are using over there a cell. Okay, so even though that we can also define it as a device which will which converts its chemical energy to this electrical energy. Okay, so therefore we are having it is also known as cell. So in lower classes we are very well known about of that cell. Now next thing is that then how we are going to denote this cell. So pictorial representation that I am going to take. So pictorial representation. So how do we have this pictorial representation? So as this cell, it is having two terminals. So one terminal it is kept longer while the another terminal is kept shorter, and there the connection is provided from these two terminal. So that terminal which is longer, it is positive terminal, while the terminal which is shorter, it is negative terminal. Okay, so thus we are having this cell. It is a two terminal device in which longer terminal it is kept longer, that is positive, while the shorter terminal is negative. Okay, now regarding to the cell over here, that we are going to learn the two terms. So one, regarding to the cell, we are going to learn over here the two terms. One, it is said to be EMF, and while the second, it is said to be terminal potential difference. Okay, this is terminal potential difference. Okay, so for simplification, let us to learn over here their diagram. So as I have considered that this is a jar in which I am going to take that electrolyte. What is inside of the cell? There is electrolyte. Okay, so here I have placed in it, these are the electrolyte. Okay, so in it, for the contact, I am going to have, this is electrode. So here I have placed, this is one of the plate which is immersed in that electrolyte. It is one of the plate, and while this is the second plate, so which is in that electrolyte. Okay, so these are what, these are said to be electrode. These are electrode. Okay, and what is inside of this jar? There is electrolyte. Okay, so this electrodes, they are connected in the circuit. For example, as I'm having, let us suppose this is a bulb. Okay, and with which I'm going to connect it. So the second end of this bulb, it is connected with that this second electrode. Okay, now over here, that inside this chemical, inside this electrolyte, there is the chemical processes going on, and due to which that the positive charge, this plate, it will become positively charged. Okay, this plate will become positively charged. So therefore this electrode is going to be that having positive charge on it, so it is high potential plate. And while this second plate, it is going to be negatively charged. If I will say that, let this plate it is going to be A, while this plate it is B. So we are getting over here that inside the electrolyte there is the chemical changes take place, and due to of it there is the deposition of positive charge on that metal A, while that negative charge get deposited on that B plate. So therefore this B electrode it is negative plate, and thus it is over here low potential plate which we are having. It is low potential, while that this metal A or that electrode A it is at a high potential. Okay, and over here that's external resistance which I have used, it is R in this situation. Okay, now over here student, that the charge when it is when the circuit is on, okay, so what will happen, the charge will start to flow from this positive terminal. Okay, so over here that the charge will start to flow from positive to negative. Okay, so let us so have this is the positive charge. Okay, this is the positive charge will which will start to flow from this positive terminal to that negative terminal. Okay, so up to here I am going to say that it goes from that circuit from the positive to the negative. Okay, so therefore it is moving just outside the cell in the circuit. Okay, so over here that work done in moving the unit positive charge outside the cell, outside the cell, outside the cell in circuit. Okay, so this is work done in moving the charge. ठीक है, और ये क्या है, आउटसाइड द सेल, मतलब कि हम उसको मूव कर रहे हैं, तो इसकी पॉजिटिव टर्मिनल से नेगेटिव टर्मिनल के बीच में हम क्या कर रहे हैं, उस पॉजिटिव चार्ज को मूव कर रहे हैं. ठीक है, सो देयरफॉर दिस इज this work done in moving the charge outside the cell in the circuit, it is said to be potential terminal potential difference. ठीक है, तो ये क्या हो गया, सेल के दो टर्मिनल के बीच का जो वर्क डन किया गया चार्ज को मूव करने के लिए, तो इसको बोला गया है टर्मिनल पोटेंशियल डिफरेंस. ओके, सो दिस इज नोन एज टर्मिनल पोटेंशियल डिफरेंस. इम्पॉर्टेंट टू नोट ओवर हेयर कि ये वर्क डन ओनली आउटसाइड द जो सेल है उस चार्ज को मूव करने के लिए किया गया. ओके, नाउ नेक्स्ट थिंग दैट विच इज ओवर हेयर, इट इज EMF. What is the meaning of EMF? That EMF it stands for electromotive force. Electromotive force. Okay, one thing which is going to mislead us, that it is regarding to force, but it is not any kind of force. okay, ये हमारे पास कोई भी फोर्स नहीं है. ये क्या कर रही है, यानी कि हमारे पास इलेक्ट्रॉन को मोशन प्रोवाइड कर रहा है. ठीक है, तो इसलिए हमारे पास जो किक प्रोवाइडेड की जाती है उसको चलने के लिए, वो हमारे पास इलेक्ट्रोमोटिव फोर्स है. बट दिस इज़ नॉट एनी फोर्स. ठीक है, ये सिंपली जो वर्क डन है उस चार्ज को मूव करने के लिए, उसको डिफाइन करने के लिए ही EMF बनाया गया है. ठीक है, नाउ लेट अस टू अंडरस्टैंड दैट व्हाट इज दिस EMF. Again I am going to consider this same situation. Here I am having that it is that jar, and inside of it I have placed, these are the two electrode. So these are two electrode, and one electrode this is going to be at a high potential due to of that deposition of positive charge on it, and this second plate it will become negatively charged. So here it is low potential, negatively charged. Okay, now here I'm going to make the connection of this bulb in that electric circuit. Okay, so here I have connected it. So this is resistance which I have used in the circuit. Okay, so this was our A plate and it was B plate. Okay, now that here we are looking that let us suppose this charge positive, it starts from this metal A. Okay, so it starts from metal A and it moves from this resistance that such as Vallabh. Okay, while it passes from this one, so it reaches to this negative terminal, and from this is the outside work done in moving the charge from its positive terminal to the negative terminal. But if we are looking over here, that cell inside the cell, this positive charge will travel from negative plate to positive plate. Okay, so thus over here we are looking that the total work done. Okay, how much is the total work done? So in this situation we are finding it out. The total work done, net work done, it is equal to in moving this unit पॉजिटिव चार्ज. तो यूनिट पॉजिटिव चार्ज को टोटल मतलब मूव करने के लिए टोटल वर्क डन क्या किया गया. सो दिस इज वर्क डन आउटसाइड द सेल प्लस work done inside the cell. Okay, so this that are two type of the work which we did over there. So over there this we did for unit positive charge, but if we are having for unit positive charge, I'm saying that unit positive charge, and if there is a charge q for q charge, then what will be the net work done? So divide both side by this q. So it is net work done in moving that charge q in one complete round. So it is work outside in moving the charge plus work inside the cell in moving the charge. Okay, so thus we are getting over here this total work done in taking the charge in one complete round, it is said to be that EMF. So it is given by E or epsilon, while that work done which is outside the cell, so this is already be defined in our this terminal potential difference. So it is given as terminal potential difference. Okay, plus that work which is inside of the cell. So inside of the cell, that it is in taking this positive charge from negative to that positive plate. So this is that potential drop inside that cell, potential difference inside that cell between the plates. Okay, so it is V dash. Okay, so this is over here that EMF. So EMF is what? So EMF is what? That it is total work done in moving the unit positive charge in one complete round. It is in one complete round. Okay, so one complete round, that inside and outside the cell. So this is said to be EMF. Okay, so thus we are getting that it is E is equal to V plus V dash. So this E it is EMF of the cell, while this V it is that terminal potential difference, short form for terminal potential difference, and this is voltage which is going to drop inside the cell, voltage drop which is inside the cell, inside cell. Okay, now let us to learn over here that as here we come to know that these charges are going to move from their negative plate to positive plate. Okay, so inside there are lots of ions which is inside of this electrolyte. Okay, so what will happen, these charges they will start to collide with each other, and due to of this collision they will oppose the flow of the charges. Okay, and similarly over there these electrodes they are also going to oppose the flow of charges. Okay, so little bit they are going to oppose the flow of charges. So therefore due to this opposition which is offered by that electrolyte and that material of the electrode, so they are going to oppose the flow of charges, and thus we are going to call this is as a resistance. What this resistance, it is going to be inside the cell. Okay, so for this purpose, let us to define this one. It is as internal resistance. Okay, so over here internal resistance. So what is internal resistance? So with small r we are going to write it as, so internal resistance is that resistance inside the cell due to its electrolyte and the electrodes for the flow of चार्जेस. ठीक है, तो जो हमारे पास इलेक्ट्रोलाइट है और जो इलेक्ट्रोड्स है वो क्या कर रहे हैं, जो चार्जेस को फ्लो होने से अपोज करते हैं. सो दिस रेजिस्टेंस विच इज़ इनसाइड, इम्पॉर्टेंट टू नोट, इनसाइड द सेल. तो ये इनसाइड द सेल की बात हो रही है. ठीक है, सो दिस इज सेड टू बी इंटरनल रेजिस्टेंस. इसको स्मॉल आर से डिनोट किया जाता है. ठीक है, एंड दिस आर, सो इट इज़ गोइंग टू डिपेंड. तो कौन से चीज़ के ऊपर ये डिपेंड कर रहा है? सो इट डिपेंड्स अपॉन, so first thing that this internal resistance, direct point I am going to write, internal resistance is inversely proportional to that temperature. टेम्परेचर इन द मीन्स कि जो समर है, समर में जो हमारे व्हीकल्स वगैरह हैं तो ये एकदम से स्टार्ट हो जाते हैं. ठीक है, जबकि जो विंटर्स हैं, विंटर्स के अंदर जो व्हीकल है वो थोड़ा सा टाइम लेता है स्टार्ट होने के लिए. ठीक है, तो इसलिए हमारे पास क्या हो गया कि विंटर में क्या होगा, टेम्परेचर कम होगा तो इंटरनल रेजिस्टेंस ज़्यादा होगा. ठीक है, और समर में क्या हो जाता है, टेम्परेचर ज़्यादा है तो इसलिए इंटरनल रेजिस्टेंस क्या होगा, कम. तो इसलिए हमारे पास आसानी से जो व्हीकल्स हैं ये समर में स्टार्ट हो जाते हैं. सेकेंड पॉइंट ओवर देयर दैट दिस इंटरनल रेजिस्टेंस इज एक्चुअली प्रोपोर्शनल टू दैट सेपरेशन बिटवीन द इलेक्ट्रोड. तो जितना ज़्यादा सेपरेशन होगा उतना ज़्यादा लॉन्गर डिस्टेंस जो है उन चार्जेस को ट्रैवल करना पड़ेगा, एंड ड्यू टू दिस दैट देयर विल बी मोर इंटरनल रेजिस्टेंस. सिमिलरली ओवर देयर दैट थर्ड पॉइंट इट इज़, जो इंटरनल रेजिस्टेंस है इट इज़ इनवर्सली टू दिस एरिया. ठीक है, मोर इज द एरिया ऑफ प्लेट. ये किसकी बात हो रही है, एरिया ऑफ इलेक्ट्रोड की बात हो रही है, जो इलेक्ट्रोड के लिए हमने प्लेट यूज़ की है. तो मोर इज द एरिया ऑफ इलेक्ट्रोड, सो लेसर विल बी दैट इंटरनल रेजिस्टेंस. ठीक है, एंड वन मोर इम्पॉर्टेंट पॉइंट विच इज़ that internal resistance is directly proportional to that concentration. ठीक है, तो जितने ज़्यादा आप कंसनट्रेटेड वहाँ पे इलेक्ट्रोलाइट यूज़ करोगे उतना ही ज़्यादा हमारे पास ये यहाँ पर जो इंटरनल रेजिस्टेंस है उसका वो इंक्रीज होता है. ओके, नाउ हाउ वी कैन शो दिस सेल विद इंटरनल रेजिस्टेंस. तो जो सेल है अब उसका इंटरनल रेजिस्टेंस के साथ कैसे रिप्रेजेंटेशन किया जा सकता है. ठीक है, तो देयर इट इज़ सेल विद इंटरनल रेजिस्टेंस, internal resistance. So we are getting that here it is the positive terminal, here it is the negative terminal, and internal resistance you will show with this one. There it is, the two terminal. Okay, so in the dotted line I am going to make a block over here. So this is the EMF of the cell, it is E, and this is the resistance of the cell, so it is R. Or sometime you will find that there is only this positive, negative, and we will write over here EMF of the cell, and it is R over here. Okay, so thus we are having, this is that representation of this cell with the internal resistance. Now look up over here that as I am having, this is that circuit in which I am going to use this that cell with internal resistance. Here I have used this cell with internal resistance. It is EMF of the cell. Here it is small r, it is that capital R. Okay, now as we have written over here one thing which is, look up over here, EMF of the cell is equal to that terminal potential difference plus V dash. Okay, so just to check over here, if I'm going to suppose that this is the total current which is coming out over here, so this current will pass from this external resistance as well as from internal resistance. Okay, so therefore how much is that total potential difference? So total potential difference is equal to that total current, and it is total resistance of the circuit. Total resistance of the circuit. Now look up over there. ये जो external resistance और internal resistance है, they are in series combination. So therefore total internal resistance, it will become R plus R. It is not internal but total resistance of the circuit. Okay, so thus over here we get, if I will multiply it is as I R plus I R, it is E, and E is equal to I R. So I R, it is that terminal potential difference in the circuit. ठीक है, तो ये हमारे पास क्या है, जस्ट दिस इज ओनली द सेल, तो इसलिए सर्किट में जो हमारे पास पोटेंशियल डिफरेंस है, ठीक है, तो दिस इज सेट टू बी टर्मिनल पोटेंशियल डिफरेंस. सो देयरफॉर दिस इज V plus this is that which is inside the cell, so it is V dash over there. ठीक है, so this is we are having. Now you will find over here that V is equal to E minus of V dash. ठीक है, that implies this V is lesser than E. ठीक है, हमें क्या करना पड़ता है, EMF से अगर हम V डैश फैक्टर कम करें तो हमारे पास ये क्या बन जाएगा, ये बन जाएगा टर्मिनल पोटेंशियल डिफरेंस. एंड over there, if V dash is 0, now when this V dash will be 0, when there is no current drawn from the cell. अगर हमारे पास I 0 हो जाता है तो V dash क्या हो जाएगा, 0 हो जाएगा. now if over there this V dash is 0, that means E is equal to V. तो हमारे पास जो टर्मिनल पोटेंशियल डिफरेंस है वो किसके बराबर हो जाता है, EMF के बराबर हो जाता है. सो वन मोर इम्पॉर्टेंट दैट थिंग यू मस्ट रिमेंबर ओवर हियर, दैट EMF of the cell is greater than V. So EMF is what? It is the maximum potential difference of the cell. While this V is what? It is that terminal potential difference between the two terminal of the cell. It is between the two terminal of cell. Okay, so over there to measure this terminal potential difference, we are using voltmeter. Remember this one, we are using voltmeter. And for this EMF of the cell, we are using potentiometer. Okay, so whenever we are going to measure this potential difference, we are using over there voltmeter, while this potentiometer help you can take for measurement of EMF the cell. So this is all from my today's video. Thank you for watching.